Okay. Hi, welcome to the Sprint 8 demo of the Taco prototype work cycle. This is Aaron Collier, developer and tech lead. We have Justin Coyne, developer, Christina Harlow, data ops specialist, I guess. Is that the word?
Data operations engineer.
Data operations engineer. Vivian Wong as our DLSS direct representative, and Hannah Frost as our product owner. We will walk through an update to several of our features that we've developed over the last couple of weeks and go over a more complex data model. We'll start with that and walk through what the more in-depth data modeling looks like now. So let me scroll to the top of this long object, and I will let Christina talk.
So this is just looking at one of the example JSON resources in our Taco GitHub repository codebase. If you want to go explore more on your own, you can see this is a JSON LD object. We're treating all resources that come into Taco as JSON LD. We've got more information beyond the context and type, which I think we've shown in previous iterations or demos, to the use of top-level properties in that JSON as the properties that we need for Taco validation or management, citation, depositor, label, etc. And then we have the use of these nested schemas or micro schemas, such as access, administration, identification, structural, later descriptive, to represent subsets of metadata that apply to the object that we want to have more granular controls or scoping of. So in this particular example, which is an example of a create or a deposit request of a resource, we see that the type gives us that it's a collection. We have the citation, which is generated from the label and eventually the Perl. We have the depositor, which is where we keep information on who updates or who's giving the resource to Taco. We have label, which is required for processing awareness of what the object is going through Taco and downstream systems. And then we have our micro schemas. Access covers how the resource gets released in our downstream publication and data exposure systems, who can access it, who can download it, if it's under copyright, if it's got any license attached. This part is being actively reworked within our policy team to figure out the best matrix for understanding what accessibility occurs for this object where. Administrative is where we've been keeping more information that's required not just in Taco, but also for other systems before or after Taco to know how to handle this resource, whether or not it's counted as deleted. And in our case, deleted means that it's become dark and only high-level administrative users can access it, not that it's been fully purged from our system. But we want to keep that it was the metadata there and indicate if it was deleted and by whom. Whether or not it should be preserved, eventually this might be expanded to say and preserved where, if we've got multiple options. And then again, information on who's updated this resource. That'll eventually go into our provenance service, which is being actively designed currently. We've got identification. This has undergone some radical remodeling even within the last week, where we can keep relationships between this digital resource and identifiers for related resources in other systems, such as in our ILS or a DOI. Here, it's just got a straightforward looking bib ID to say that this digital object has some metadata describing a different manifestation in our catalog so that we can link those. And then we've got structural. All objects going into Taco are expected to have a has agreement structural relationship. This indicates the agreement by which the resource was given to our Stanford Digital Repository. And then the structural information, which should look very similar to people familiar with PCDM, to the use of PCDM and LDP within Hydros and Vera communities. Here we've got a long list of members. These are objects that are part of the collection, and as part of our validation, which we'll see later, we want to make sure that these exist when a collection is loaded into Taco, and that all of these are objects. We don't want a collection containing a file directly, for example. We have isTargetOf, which is the start or a holder space for where we want to use an annotations model to have user-generated tags for things like collections. And then we have orders, where we heavily reuse the Europeana approaches, Europeana and IIIF approaches to how to capture multiple possible sequences for a resource. Here you see that we're using an array. There are some open questions about confirming that this is order safe, but we have here a sequence with an array of those same druids, and it shows this is the primary order. This is modeled in such a way that we could have multiple orders with particular types, so that we know in one representation we display the resources this way, and another we display it that way. That's a pretty brief overview of our modeling so far, but again, you can see the examples and our application profiles in the Taco GitHub repository. All right, Aaron, I'm going to hand it back to you.
Thank you, Christina. That was really very informative. So we're going to attempt to deposit an item now. And the first thing, we pull this command over. And the first thing I want to show is that if we do not include now what we are passing in the header information for the person actually depositing the object, if we do not include that information, we get a, oops, I've got to change my paths to localhost from the demo. Whoops, oh, because we did it live last time. We get unauthenticated, there were no credentials provided. So we are checking that credential path on all of our requests now. Note that we can also, we're tracking the domain with the SUNET ID so that we can offer external to Stanford users the possibility to use this as well. So we'll capture that information. So let me, and I need to change this again. So now we'll actually try to deposit a resource with our SUNET ID, and we get an ID back. And the resource that we that we're depositing, we'll take a quick look at. It is a smaller example than before, but you'll notice the same JSON LD structure. And if we try to request that object, from our system, you'll notice we get an unauthenticated message because we haven't provided the credentials that we're expecting on that path. So we need to include the on behalf of credentials in the header as we did before. Oops. That's a long ID. And we'll pre-print that so we can see it. So now with the credentials, we're able to request that object, and you'll notice the format closely follows the format that we looked at before. So this was our example JSON LD that we passed in, and we're getting the same structure out again. We will update that object, and let's take a look at what the update looks like. So we're going to update the same object. You'll notice that the input for our update looks very similar, but we're updating both the label here to show that we can update our top level fields, and we're changing from the existing access policy here of download and access a world. We're going to change that policy to dark. So access will be dark and download will be dark in our update. So we'll do the same thing. We need our credentials, and it's wrong command. Oopsie. We need our credentials. I need to change this to localhost. And we're doing a patch against the ID that we created up here. Notice we got the ID back that showed us that we did a good request. So we can curl that request again. Again, providing our credentials, and notice now we've updated both the label and we have turned the access from world to dark on access and download. So we're able to update and overlay any changes at any level of nesting within our micro schemas. The next thing we're going to show is an update to our file endpoint. All right. This will upload a file to our S3 bucket. And again, we get an ID. We can do the same. This ID is actually representative of a metadata object related to that file. So we'll take a look at what that metadata object looks like. And we get back that it's a text file. We capture the MIME type now, and we capture the file name within that object. And we've got our ID and ID information within that metadata object. This map will be expanding as well as we develop those structures. So that's a new update to our upload file. And the final feature that we will show for this demo is actually deleting an object. So let's delete this file object that this file metadata object that we just created. And we don't need a response from that because the file is now gone. And if we would do a curl, it's not print because it doesn't. We don't get any response back. So the metadata object is now gone from our delete call. So those are the new features that we've added recently. I'd like to show also what, now that we're doing schema validation, what it looks like if we try to add a bad file or an object that doesn't validate against our metadata maps. And let's take a look at the one that we looked at before, which is create. What's the name of that file? Create. Let's see. Create, yes, 64, 6 CD, 8, 717, JSON. Did it again. Should have changed these all before. Oh well. Did I just patch that? How did I patch that? I'm confusing myself now. Hold on. Let me clear this up. I'm trying to patch an update. That's what editing is for. Okay, so we tried to update the resource that we looked at earlier that had a long structural map, and we don't have those objects. So now we've validated against that map that we don't have those objects. So we return an error saying that this collection does not validate because the objects we're trying to be members of it don't exist in our system yet. So that's one error that you might see. Another error would be if a object doesn't match the mapping, doesn't validate against the mapping. So we'll use an invalid version here. Invalid dash. And this error is a little more complex and harder to read, but it tells us that it's iterated through all of our possible validation maps, and it didn't match any of them. So we know that the object that was sent to us has fields or a structure that doesn't match anything that we would accept. So we're not allowing that to just pass through. So we're doing that level of validation now. And I think that was all we wanted to show in this demo. If anybody else has anything I missed, let me know.
Just wanted to add one comment. Thank you for showing this, Aaron. In that last bit, you see that it's actually spitting out errors based off of JSON schema validation. It means that we can have our data specifications, our metadata specifications stored in one spot, and the code itself doesn't have to have a lot of hard written code to check for this field is present, this field is not present. It has this type of value necessarily. It doesn't cover all validation cases, but it's a really good start and a different practice than a lot of our other previous repository code bases have done with regards to metadata validation.
Yeah, thank you for clarifying that. Much better said than I would have remembered to say. Cool. Thank you very much for watching our demo for this Sprint 8 of the Taco Prototype Project.